Okay. Just to remind you, we have covered up to tutorial 3, that is NFA DFA, and I will open this because we have completed NFA DFA tutorials. And if you notice, after tutorial 3, of course in sequence is tutorial 4, and tutorial 4 will say pumping lemma. Tutorial 4 will say pumping lemma. But what we will do is, we will do tutorial 5 PDA. Then we come back to pumping lemma. Okay. The reason is, if you look at the lecture, lecture topics. You see, lecture 3 says pumping lemma and PDA. Okay. So this is actually one topic. So where here the problem solving is different. Here the problem solving is different. So here you had tutorial 3, right? So in the tutorial, this is labeled as tutorial 4 and this as 5, right? But we will do PDA first and then we'll come back to pumping lemma. You ask me why? Because pumping lemma is not covered for your test. Okay? So only grammar, NFA, DFA, and then PDA. These are 3 topics for the test. Okay. So I'm not telling this now. It is there from day 1. If you look at times, it is there from day 1. What are the topics for the test? See, written test. Conducted face to face is week 9 for a duration of 1 hour. The topics of the test are the topics covered in tutorial 1, 2, 3, and 5. 1, 2, 3, and 5. Language and grammar, past trees, non-deterministic finite automator, and cushion automator. Okay. So whether we will have the test in the 9th week or not, that every semester happens. We always postpone by 1 week. The reason is syllabus coverage. Because I am unable to rush like what we do in Australia or the US. Every week cover one topic. It's not possible here. Okay? I am not saying in Taylor's. In the Malaysian context, it's not possible. Okay? It's a different. There is no comparison. Okay? It doesn't mean they are superior, they are inferior. No. And that's why I said there is no comparison. Yeah. So what happens is it takes time to cover the topics. Okay, in the Asian or Malaysian context. Okay. We took 2 weeks for grammar. We took 2 weeks for 2 weeks for grammar. Yeah, 2 weeks for grammar. 1 week for past trees. 3 weeks gone already. Then we took 2 weeks for NFA DFA. And the first week there is only one lecture. There's no tutorial left. The very first week we only do overview of the subject. We just get introduce the subject. Okay. So we are in 7th week. We have managed to finish only 3 tutorials. It's normal. It's normal. Don't worry. Oh, we have only covered 3 tutorials. Next week is a digital learning week. Are we going to complete the syllabus or not? Yes, we will complete. Don't worry. Okay. On time. Don't worry. Usually, when we start with the grammar, students take time to understand grammar because it's completely new. NFA, DFA also is completely new. Okay. PDA we will finish fast, and Turing machine also we will finish fast, because you will understand them faster, because you will see a lot of familiarity when you go to PDA and Turing machine. Okay. Cryptography is only 1 week. We can finish it very fast, because just a formula, apply the formula, and tutorial done. Okay. But now next week is your independent learning week, and week after next is your 9th week. The test says 9th week, but we need to cover PDA before we go for the test. Maybe we push the test to 10th week. As I said, this always happens. Okay, yeah, don't worry about it. Yeah. And unfortunately, last Thursday I had no choice. Normally, in my experience, I never do. But last week I had no choice. I have to push the class or cancel the class. I cannot say cancel the class because it is replaced. Okay, it was not held last week. But as I said, I couldn't discuss the tutorial class when to replace, because some said I am not available. So I was unable to find a common time. So I can speak about the common time only on Thursday. This Thursday is week once. Majority will be there. I can find a common time, fix it, and the class that we lost last Thursday will be replaced. But that cannot happen this week or next week, because next week is a week. So maybe week after next week when you come back, we will do the replacement. Don't worry about it. Okay, it's my responsibility to replace the lost class last Thursday. Okay. So today we are supposed to do tutorials on PDA, but we have not discussed anything about PDA. Correct, right? Yeah. I am not sure how many of you looked at this. Let me show you. If you look at here, there is something called as PDA introduction. Something called as PDA introduction. I don't know how many of you went through this. Okay, how many of you went through this? So maybe I will discuss that today. So we may not solve problems, because without discussing something we cannot solve. Okay, and yeah. So tutorials on PDA we will do on this Thursday. So that before you go to Thursday, you will have some grasp of what a PDA is and why we go for PDA. Okay? So I will do that now. I will do that today. Okay? PDA introduction. It is here. You can go through later. So I'm going to use the whiteboard. This language that is given here, A length n, B length n, where n is greater than or equal to 0. This language is not regular. Okay. So why we say this language is not regular, or when we say a language is regular? A language is regular, okay, if it can be represented in terms of a regular grammar or regular expression, okay, regular grammar or regular expression, or can be implemented in terms of an NFA or DFA. I repeat one more time. A language is regular if we can represent the language in terms of regular expression, or in terms of regular grammar, okay, or in terms of an NFA-DFA. Okay, so we cannot write this language in terms of a regular expression. Why? It means that if I were to write as a regular expression, I have to write like this. The language is equal to A connect star, B connect star. I have to write like this. If I were to write this language in terms of a regular expression. Regular expression means it is made up of the symbols, open brackets, close brackets, connect star, the symbol phi, what else that? Lambda is lambda union operator. Phi lambda union. So we call this as regular set of symbols that are used to represent a regular expression. Okay, and we can combine these symbols with sigma. Sigma represents alphabet set. So every language has an alphabet set. So you can combine these symbols with the alphabet set of a language, then it becomes a regular language. Okay. So if I want to write this as a regular language, I have to write like this. But this is not the regular expression for this language. What this language says is the alphabets are A or B. Okay. Where the strings, the pattern of strings are A length than followed by B length than, meaning the A's are followed by B's always, okay, and the length of A and B are always equal. If n takes a value 0, then this language will be empty string. Okay, if n is 1, A B, n is 2, A A B B, n is 3, triple A triple B. That's why I said in very simple terms. This language says that the alphabets are A or B, and A's are followed by B's, and the length of A and B are always equal. Okay. Here, this is not correct. Why? Means when I write A connect star, B connect star, this connect star can take any value. Okay. When this connect star is 10, this connect star need not be 10. But here, when I say n, if n is 10, here also is 10. If n is 100 here also is 100, because both take the loop variable as n. Okay, but here they can take different values. So the length of A and B will not be equal or need not be equal. Okay, so this is not the right answer for this. So what I am trying to say is we cannot write this language in terms of a regular expression. We cannot write this language in terms of a regular expression. Do you understand me, every one of you? Okay. So with this itself, I can conclude this language is not regular. Okay. But I said, if I can write the language in terms of a regular expression, or I can write a regular grammar, or I can represent or I can represent in terms of NFA DFA, then it is a regular language. Okay. Now, regular grammar I'm not going to show you, but I'm going to show you whether an NFA DFA is possible. NFA DFA for this is not possible. Why in the sense? So if at all I want to construct an NFA for this, I will build an NFA like this. Okay, I have no choice. I have to build like this. That's what I think you see here as well in the introduction to PDA. Yeah. and I crossed it. Why the sense? Even though it's an NFA, this is not an NFA for this. Why? What are the example strings here? Ignore lambda. Lambda is an example string, but we give lambda means we are giving nothing as input. Okay, nothing will be processed. So I ignore lambda. So next is AB. I just stop. So why I stop means I already see the pattern. A's followed by B's. The number of A's and B's are always equal. All these valid strings will be accepted by this machine. Correct, right? AB, A, B. 2A will be right. First A, second A, B, B. Don't forget NFA. There are paths that will lead to failure, but there are also paths that lead to success. Okay? It will accept all valid strings. This machine will also accept all invalid strings. Invalid, right? It will accept A, B, B. Okay. Maybe 3 A's, 5 B's. It will accept 1, 2, 3. 1, 2, 3, 4. Meaning, this NFA will also accept invalid string. Okay? NFA, for a valid string, there may be many paths. Some path will lead to success, some path will lead to failure. But it cannot accept invalid string. Not even one invalid string. Okay? So, when I cannot represent this language in terms of an NFA, DFA is also not possible. Okay? NFA and DFA are equal in terms of capability. Okay? Because NFA can be converted to a DFA, DFA can be converted to a NFA. So when that is possible, it means they are equal in terms of capability. Usually we say DFA is a subset of NFA. We can have many NFAs, but only one DFA for a given language specification. Okay? So that's why I have striked it off. So this is not an NFA for this language because it's wrong. Okay? So an NFA or a DFA is not possible. So it means this language is not regular. Okay? Okay, fine. Not regular is okay. But how to implement this? I want to implement this language and see how it works. Okay? That's why we go for automator. That's why we go for machines, NFA, DFA. But we cannot implement this language in terms of NFA or a DFA because it is not regular. But how to realize this, how to implement this, that's why we go for PDA. Okay? So what is the cause that makes this language to be not regular? Okay? One reason is N is unbounded. Okay? One reason N is unbounded. Unbounded means what is the maximum value N can take? Infinity. Minimum value is 0, maximum value is infinity. No end. So it becomes infinite. Okay? Infinite. So that is one reason. So it means when we say n is infinite, it means infinite memory. Okay? Memory has to be finite, we cannot have infinite memory. Right? So that is one reason, but it's a bit tricky. I just stop there, don't extend your thoughts further than that, because there are languages which have unboundedness like this, but they are still regular. Okay, that's why we go to pumping lemma. I will discuss that when we go to pumping lemma. Okay, I will recall this. Okay, so that's why I said one reason for this language to be not regular is n is unbounded. Okay, but it doesn't mean if n is unbounded, always the language is not regular. No, there are exceptions. Okay, and so when there are exceptions, we will discuss that when we go to pumping lemma. Okay, that's why I pushed pumping lemma after discussing PDA, because for me, for everything there is a purpose. Okay. in research we call it as motivation. There's a motivation. So motivation to go to PDA. Why we go for PDA? Because we cannot implement a regular language in terms of NFA. Then how to implement? That's why we go for PDA. Okay. So I said here n is bounded, right? Bounded means you need to have. N is unbounded. Unbounded means it is infinite. So infinite means you need infinite memory. Okay. Yeah. So what happens is why we cannot implement this in terms of NFA DFA when n is unbounded means NFA DFA has no memory. Or better, NFA DFA has limited memory. Limited memory in the sense it can only remember the current state. It cannot remember the previous state. Okay, NFA DFA has limited memory. It can remember only the current state. It cannot remember the previous state. Okay. So what do you mean by current state and previous state? Let me give an example. So this language is not regular, right? So if I take n as 2, the example string is going to be AABB. Okay. So how do I produce AABB? So what is this language? A is followed by A's is followed by B's, and the length of A and B are always equal. Correct, right? The number of A's and B's are always equal. Okay. So if n is 10, for example, then I have to produce 10 A's. Correct, right? So how do I do? I will count them. I will literally count them. Okay. Any one of us will do the same. We will literally count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. If you have to do with a computer, this count has to be stored somewhere. Why, you know? So that the computer can produce equal number of A's. How many A's it has produced? 10 A's. This value 10, the count, has to be stored temporarily in the memory. Usually it will be stored in the stack in your computer. Okay? So that it can remember and produce 5, 6, 7, 8, 9, 10. Even you write a program, you have to count it on. Maybe for I is equal to 1 to 10, write equal number of B, something like that. You have to write. Yeah. So when your NFA DFA can only store the current state, it cannot store the previous state. This count cannot be stored. Because when it comes to B, this is your current state. This is your previous state. Okay? NFA DFA remembers only the current state. So if it writes B, that is the current state. It cannot store this count because it's the previous state. So if it doesn't store the count, it cannot produce equal number of these. That's why I said this n is unbounded. Unbounded. So NFA DFA has limited memory. Limited memory means it can remember only the current state. It cannot remember or store the previous state. Okay. But here we need to remember the count. So how to do it? So what is the problem here? Limited memory. If the problem of limited memory can be overcome, then this problem can be solved. And that's why we go for a PDA. And that's what you're seeing here. PDA uses a stack. Stack as the memory. Because what is the problem here? Memory is the problem. That's why we cannot solve this problem. Okay. So we can overcome the memory limitation. Then we can realize or implement regular languages. Okay. So that's why we go for a PDA. So a PDA uses a stack as the memory. Okay. And that's why it is called as a PDA. PDA stands for push down automator. Okay. Stack always follows LIFO principle. You all know that. You have learned stack in your data structures and algorithms, right? So last in, first out. Okay. So whichever came last will come out first. Okay. So we call this as the stack pointer. Okay. We call this as the stack pointer. So rather, I will show you the stack pointer. And where is your stack top? This is a stack top. The last filled in. location of the memory is the stack top, right? So now this can be easily implemented with the help of a PDA. Okay, how? I'm going to show you. Your stack. Okay. So I'm taking n as 2. If n is 2, then the string will be AABB, right? So how to implement this? How to ensure that the number of A's and B's are equal? Okay. So this is how we do conceptually. Read the first letter, which is an A. Push A into the stack. Write A. Read the next input alphabet, which is an A. Push A into the stack and write the A. Next letter is B. Once B means, we are writing the instruction like this. B means pop the A. I said last in, first out, you cannot pop this A. This is at the bottom of the stack. You can only pop something out of the stack on the top. Stack top. So pop the A, write B. Pop the A, write B. Check whether stack is empty. No. We still have alphabets read. Next letter is B. Read B. Pop the A. Write the B. Check whether stack is empty. Stack is empty. The entire string has been processed. Valid string. So what we are trying to do means, basically we are counting with the help of a stack. Okay. How we are counting with the help of stack? With the help of push and pop. Okay. If the number of push and pop are equal, then the number of A's and B's are equal. Okay. So A means we push A, B means we pop A. So if the number of push and pops are equal, then it means the number of A's and B's are equal. So what happens if it is an invalid string, something like this? So what is the program we did? A means push A. A means push A. A means push A. B means pop A. B means pop A. Once the entire string has been processed, stack is checked, stack is not empty. Meaning number of A's and B's are unequal. Okay. I'll show you another scenario. This is also invalid string. A means push A. A means push A. B means pop A. B means pop A. Entire string has not been processed. B means instruction says pop A. Stack is already empty. So when stack is already empty, we cannot pop A from an empty stack. Okay, we call this as stack violation. Okay, we are violating the architecture of a stack. Okay, we cannot pop an A from an empty stack. A magician can do. From an empty pocket, he may pull out a kerchief, or from his hat, he may pull out a pigeon or a rabbit. Right? That is black magic. It's not science. This is science. Okay? Magic is a trick, you all know, right? Yeah. Nobody can bring a pigeon or a cat or a rabbit out of an empty hat. It's impossible. Right? They do a trick. It does not go there. So, okay. Simple. That's why we go for a PDA. Okay. So the NFA, DFA, memory is limited. Limited in the sense, it can only store the current state, it cannot store the previous state. So regular languages cannot be implemented. Because regular language, mostly n will be unbounded, unlimited. Okay. So to overcome the difficulty, we go for PDA. So with PDA, stack is used as the memory. Okay. So using push and pop, we try to manipulate. So any questions? I saw only half an hour. I cannot go for tutorials because there are two other batches going on with the tutor. To him I told just do revision of the past topics, and he said, okay sir, give me your previous test paper, I will do revision. So he's doing revision today and tomorrow, the other batches. But I am introducing this to you, okay? Because without teaching PDA, the students cannot give it. Not only them, you also cannot do PDA tutorials. Okay. So as I said, tutorials I'll jump into on Thursday. Okay. So I will explain the example problem, and then we will do, depending on time for that, we do one or two problems. Okay. So I just stop here. So any questions or doubts you have so far, you can ask me. Any questions or doubts you have, please feel free to ask me. Let it be grammar or NFA, DFA, past piece. Or maybe I just go by topic so that I show you, so that you have any questions, you can. I prompt you with the questions so that easier for you if you have any questions to ask. Okay, NFA, DFA, you have any questions? With NFA, DFA, you have any questions? End statement, you mean final statement? Yeah, after a final statement. We need to have a final statement for both NFA as well as for DFA. Otherwise, how the question will hold? Yeah. He needs an error state. Not necessarily a DFA need to have an error state. Not necessarily. There are two conditions. There are two conditions stated. These two conditions, if they are satisfied, it is a DFA. So guys, I've explained this in the class. Not all DFAs will have an error state. Not necessarily every DFA must have an error state. Yeah. So it depends on the problem specification or language specification. Okay. So some DFA will have an error state, not all DFAs. Okay. Yeah. And if you ask me how to differentiate an NFA and DFA, a DFA should satisfy these two conditions. Okay. NFA will not satisfy these two conditions. Okay. See, for example, if you take any NFA, for example, this is an NFA. Because if you take Q0, it has to have an outgoing arrow. It must have an outgoing arrow for every input alphabet. But only outgoing arrow for A is there. B is not there. Okay. And if you see here, at Q2, B is redundant. There are two outgoing arrows for B. There's a choice, NFA. So if you look at the DFA for this, it will satisfy both the conditions. If you look at every state, it will have an outgoing arrow for both the input alphabets A and B. and there will be no redundancy. No redundancy at all. Okay? This machine has an error state. I also told you, we can label this as an error state, not necessarily. You can even label this as Q5. Instead of E, error, you can also label it as Q5. No harm. Okay, because if you go, the machine cannot halt here. If the string is valid, the machine will halt here. If the machine halts anywhere else, here or here or here or here or here, it's going to be an invalid string. Okay? So whether it is an NFA or a DFA, the machine must halt only in the final state. If it halts at the final state, then it is a valid string. If the machine halts at any other state, then it is an invalid string. Okay? So did you all try the question number 3A we did in class, I remember. Sorry. Yeah, 3A we did in class. 3B and 3C, did you all try at home? Did you have any difficulty with 3C? No, right? Yeah. Of course, just now I shared the answer. So you have to look at the answer at my time as well. But see, the thought is very simple. I'm just translating what is there. It says the strings are over A or B or C that do not contain the substring AA. So what I will do is, I will take the machine like this. It says that do not contain the substring AA, right? So I will not make this as a final state. I will make this as a final state. Right? So I can have 1A, right? We can also have 1B, right? We can have 1B, we can have 1C. So A means ups up, B means ups up, C means ups up. So I can have many B's as well, right? I can have many C's as well. You can have BA. So how to do BA? BA. There's a string BA. There's also a string ABBA. A, B. But if you put the A here, it will be dangerous because you have an A here. A, no, you can accept many A's cannot. Of course, your answer will not have answers for the assignment question. Yeah, for this, there won't be any answers. Why? In the sense, your assignment 1 is over only when the test is over. Okay? Yeah. Only when the test is over, the assignment 1 is over. So, I will release the answers for assignment questions after the test is over. Okay, but I'm just discussing, right? So whether you have any difficulty here. Here also you have ABBA, right? BA also there. So how to do? It seems to work, but once we come here, how ABC will work? A, B, C, no issue. The only problem is with A, B, B, A. A, B, B. A means it goes here. How to do A, B, B, A? both ABBA as well as VABA. VABA is a valid string, right? VABA is a valid string, right? VABA is a valid string because it does not have two A's. The question says the strings can be made up of any of these alphabets. So I can even have a string CAB. Okay. CAB, again when I say CAB, how to CAB here? See, this machine works for some of the valid strings. Question is how to do ABBA, BABA, maybe CAB as well. Done. Yeah, I might try it. No harm. That's all. No, your question will work, but it won't work if I have only A alone, B alone, C alone. Don't panic. No mind. If you're wrong, it's not a crime. Relax. Do you need that looping back to the last? Yes. This can be done here itself, right? Okay, you can erase it. Oh, you right. What you want to do there? Okay, yeah. Is that complete? I have the same answer. Anyone? Yeah. You have a different answer. I don't know. We can't produce lambda. Lambda is not a string. empty string is a valid string, but empty string means nothing. Lambda means nothing. You understand? See, string means string. See, repeatedly don't worry. Every semester students have this question and doubt. Okay. These are strings. This is also a string. String means made up of alphabets. Okay. When we say lambda, it is an empty string. Empty string means nothing. So we want to represent nothing with a symbol, so we use lambda. That's all. Okay. So why I said don't think of lambda given as input. If you are saying lambda as input, if you are saying lambda as input here, it means you are getting nothing as input. You understand? If you are getting nothing as input, nothing will be processed. Okay? So it is meaningless to put lambda here. Lambda, comma a, comma b, comma c. You are saying nothing, comma a, comma b, comma c. You understand me? Yeah. So is this correct? So if she has a different answer, let us see her answer. I am not saying yours is wrong. Okay, I'm not concluding it. I'm leaving some space for you guys to think. Yeah, come. Maybe you can do it here. Continue as the first one. Okay, you can fill in the blanks. Fill in the blanks here itself. You're just going to add something here, is it? Okay. So you are making this as a final state. And but when you make this as a final state, you will have AA. AA is not also this. You can use the. That's the answer you asked. Making this one as a final state, right? No, we cannot make this as a final state because this, if you make this as final state, you will end up with 2A's. 2A's cannot. It says that do not contain the substring AA. Okay, let's check. Don't worry, is redundant. That's NFA. The NFA, man. So he's asking BC, is it redundant or not? Yes, redundant because you have BC here, you also have BC here. You have two outgoing arrows for BC and Q0. Don't worry, it is redundant or not because the question is to construct an NFA. It's not asking about DFA. Okay? Let's check this. We can have purely A's. I mean, we have 1A, we can have 1B, 1C, no issue. Can I have purely B's? Yes, I can have. This one allows that. I can have any number of B's. This one also allows any number of C's. Okay? This way also I can have any number of B's. 1B, 2B, 3B, 4B, 5B, 6B, you know. Yeah. So how about A, B, B, A? A, B, B, A. B, A, B, A. B, A, B, A. Can C, A, B. Of course, these are valid string. There are many. There is an NFA. There are many other paths, but all paths may not lead to success. For example, for C, A, B, if you take this path here, C, you are stuck. If you take this path for C here, you are stuck because there is no route for A. But there is a route here, C, A, B. That's why we say non-deterministic. How the machine knows for cab, it has to take this path, C, A, B. How it knows? It doesn't know. Okay, that's why we go for deterministic. Okay? Yeah. So this works. So it's the right answer.
You know, this is the right answer. 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 This is the right
you should confidently say. How to confidently say? Just check with some valid string. With this machine, you can never produce two A's because one A, that's all. You cannot produce two consecutive A's. I did this based on the specification. I just reflect the same thought. But here, there are issues. If you go in this direction, how to produce ABBA? Cannot, because A means I am forced to go here. B means I am forced to go here. I can do A, B, B. But if I loop A here, it's dangerous. It will work for this A, B, B, A. But this will allow two consecutive A's. 1A. No, it won't allow two consecutive A's. 1A, if you all say it is reject. 1A, 2A seems to work. 1A, 2A, no. 1A, 2A also cannot. How about BA, BA? B, A, B, A. Cannot. Unless I make this as a final state. If I make this as a final state, then AA will be allowed. Cannot. So this direction won't work. Okay? Yeah. This direction won't work. Even CAB, CAB works, but BABA doesn't work. BABA doesn't work. Yeah. So this one is the right answer. So what I want to show you, why I didn't tell your answers right or wrong means, I want to show you how even I verify whether an answer is right or wrong in the sense by giving some valid string and giving some invalid strings. If the machine is correct, it should accept valid strings. Okay? And it should not accept invalid strings. If the machine also accepts invalid string, the machine is wrong. Okay? If the machine accepts only valid string, does not accept invalid string, then the machine is correct. Okay? So how you gain speed means by practicing. By practicing, you can gain speed. That's all. That's why we say, our practice makes a person perfect, right? So here there is no shortcut. By practice only, you gain speed. Okay? Any questions before we go for attendance? So don't worry about the test. Maybe on Thursday we shall fix the test date as well. I know it is your 9 times is 9th week. The date is also there. Anyway, we'll be doing our class. Okay. Yeah. So don't worry because I don't want to rush. I want each one of you to get good marks in your test because it's going to contribute to your coursework marks. Okay. Yeah. And while I share the attendance, after you come back from the next week is your independent learning week. After you come back, so every week online I will open a consultancy class, which I've been telling you last week. I will do that once you come back after the independent learning week. So every week I will open 1 hour online consultation class. Whoever has doubts, anything you want to clarify, check, you can join. That 1 hour I'll be there online. Whether you are there or I'll be there online. Okay? Every week. Starting immediately after your independent learning week. That's from 9th week onwards. Next week is 8th week. So 9th week onwards I will schedule a time. Okay? So that you can clarify any questions you have.